Welcome to our video on correlation and correlation coefficients. Today, we'll unravel why these concepts can be so confusing and equip you with a clear understanding. Let's start with correlation. Correlation describes a relationship where two variables change together. If variable x increases as variable y increases, or x decreases as y decreases, we have a positive correlation. Think of it as both variables moving in the same direction. Conversely, if x increases as y decreases, or vice versa, we have a negative correlation, where the variables move in opposite directions. But remember, there's more to the story than just direction. This brings us to the correlation coefficient, a number that quantifies both the strength and direction of the linear relationship. The correlation coefficient ranges from -1 to +1, passing through 0. A correlation coefficient of +1 signifies a perfect positive correlation. A coefficient of -1 signifies a perfect negative correlation. A coefficient of 0 implies no linear relationship between the variables. The sign positive or negative indicates the direction of the correlation. The magnitude or absolute value represents the strength. A correlation coefficient closer to positive or -1 indicates a strong relationship, meaning the data points cluster closely around a line. Conversely, a coefficient closer to 0 signifies a weak relationship with the data points scattered more widely. Let's visualize this. Imagine scatter plots. If the correlation coefficient, denoted as a sub xy, is 1, all points lie perfectly on a line with a positive slope. As the coefficient decreases to 0.8, then 0.4, the points become more dispersed. At 0, there's no discernible pattern. The same applies in the negative direction. At -0.4, -0.8, and -1, the points align on a line with a negative slope, becoming more tightly clustered as we approach -1. It's crucial to remember that correlation does not equal causation. Causation means one variable directly causes a change in another. For example, eating dinner causes fullness. Income allows for spending. Customer satisfaction encourages repeat visits. In these cases, there's a clear cause and effect relationship. However, just because two things are correlated doesn't mean one causes the other. There might be other factors at play, or the relationship could be coincidental. For instance, ice cream sales and crime rates might be positively correlated, but ice cream doesn't cause crime. Both might increase during the summer months due to higher temperatures. In summary, correlation describes the strength and direction of a linear relationship between variables, quantified by the correlation coefficient. While correlation can be a useful tool for identifying potential relationships, it is vital to avoid assuming causation based solely on correlation. Always consider other possible explanations and conduct further research to establish causality.